All right, now we're going to get into the graphing of our sinusoidal functions. And one thing that I'm going to suggest that you maybe do with your assignment things is you might want to choose to rescale the drawings just to make it a little bit easier for you, which I'm going to do right here, just because I think it'll be easier in doing this from our homes. I think that'll be way easier for me to explain it that way. All right, so let's take a look at this function, y equals 3 sine of 4x, and hopefully you see two things that are happening. There is a horizontal compression that's taken place, as well as a vertical stretch that's happening. So before you go anywhere and start to graph this out, answer these 4 questions right away. Find these things first. Know that your period, so we're going to take 2 pi, we're going to divide it by 4, so that gives us pi over 2. So that's going to give us our period. Our midline, we're not adding anything, so it's going to stay at 0. Our amplitude, our value of A here is 3. Absolute value of 3 is 3. And there is no phase shift that we have to worry about at this time. So starting out, probably the hardest part for people is going to be working with your x-axis and getting that labeled. So the thing that you've got to think about is that sine and cosine, the parent function itself, is really made up of 5 critical points. And since we are working with the sine function, I'm just going to kind of sketch up here at the top. Your sine function starts at 0, goes up to the maximum, comes back to the midline, goes down to the minimum, comes back to the midline. So if you can graph out those 5 points, it makes it easy to graph. Now, with that being said, too, it's being those 5 points, divide your period into 4 equal sections, which if you think about a circle's divided up into 4 equal parts to it, and so each interval is 1/4 of the full circle. So what I am suggesting that you do here is that you take your period of pi over 2 and you take 1/4 of that. So if you take 1/4 of pi over 2, that gives us pi over 8. And what I'm going to do right here is I am going to divide up my x-axis here into 4 equal parts. So I have pi over 8. 2 pi over 8 would be the same thing as pi over 4. Then I have 3 pi over 8. 4 pi over 8, which would be pi over 2. Now I could do the same thing for the x-axis, or the negative side as well. But what this is just doing is it's putting my period here to be at pi over 2, which is what I want. All right, then you have your midline, and our midline is at 0. And then we have an amplitude of 3, which means you have to go 3 units above, 3 units below that midline. Now I'm going to plot out my 5 points. Again, it's a sine function, so we're starting at your midline. At the next value here, so at 1/4 of your total period, you are going to be up at your maximum. At 1/2 of your total period, you're going to be at the midline again. At 3/4, you're going to be at the minimum, and then you'll be back at your midline. And so here I have a graph of 1 period of the function. Notice the period is 2 pi, my amplitude is 3. I don't have a phase shift or horizontal shift, vertical shift happening at this point. You could by all means then do the same thing as you look at, I think I'm off a little bit here, maybe not. Yeah, I think, sorry, I'm off a point here, whatever. But you could also be looking at going and continuing into the negative direction as well. All right, so let's take a look at another example here. I want to get right to the graph. think that shifted over a little bit. Let's move it back. Okay, so once again, just ignore this, rescale it so that it makes sense for you. Our value of b is 1/3, so I'm going to be taking 2 pi and dividing it by 1/3, which means I'm multiplying by 3. So 6 pi is going to be our period. Our midline is at our k value here, so y equals 1. Shifting it up 1, we have an amplitude of 2, and there's no phase shift to worry about quite yet. So again, probably the hardest part is the period point part of this, and I again just like to break it up into 4 equal parts. So I'm going to take 1/4 of 6 pi. So that gives us 3 pi over 2. So 1/4 is 3 pi over 2. 2/4 would be 6 pi over 2, which would be 3 pi. 6 pi over 2, then that would take us to 9 pi over 2. And then that would take us to 12 pi over 2, which is 6 pi. So here I have my, as if you were to think about it, you were really stretching it out. You're going from 2 pi to 6 pi. So we're really stretching it by a factor of 3, but just for our purposes to kind of help us graph this out. All right, so that's the hard part, I think. Midline is at 1, and then we have an amplitude of 2. So you got to go 2 units above, 2 units below. Now this time you're working with your cosine function, and so cosine starts at the maximum. 1/4 of the way through the period it goes to the midline, half the way it goes to the minimum, 3/4 of the way it goes through the midline again, and then it goes back up to the maximum. So that is its 5 critical points. So we got to start at 3. Then at 3 pi over 2, we're going through our midline. At 3 pi, we're down at the minimum. 9 pi over 2, I'm back at my midline. And at 6 pi, we hit the maximum. And so there's one period of the function, which once again, you can continue this to make it a little bit bigger if you wanted to. But labeling your axes and things is going to be important so that we can see exactly what kind of stretch is happening. All right, let's take a look at one with a phase shift. So our period, we're going to take 2 pi and divide it by 1/2. So that means 4 pi is going to be our period. Midline, I am not adding anything, so midline is going to stay at 0. Our amplitude, absolute value of -5 is 5, but just be careful because there is going to be a reflection over our x-axis in the end. And a phase shift here, we are going to the right, pi over 2. All right, so I'm going to take 1/4 of 4 pi, which is a nice easy one to work with, so that's pi. So here I'm going to split this graph up into 4 equal sections. Here's pi, this would be 2 pi, 3 pi, 4 pi. Love it when it's nice easy ones to work with. Midline is going to be at 0. Our amplitude is 5, and actually I'm going to have to go all the way up to +5, all the way down to -5. And what I personally like to do is I like to graph out my function first and then do the phase shift, just because I think that's easier for me. And then I will sometimes do the reflection at the end, or sometimes I'll do the reflection at the beginning. It just kind of depends on what I'm feeling at the time, I guess. You are working with the sine function here, so I'm going to just graph it out right now as sine with a few of these. So sine would start at the midline. It's going to go up to the maximum, back to the midline, down to the minimum, and back to its midline. So this is our graph without the shift and without the reflection. If I want to put the reflection into here, and I'll just do this in pink then, now I'm going to reflect it across my x-axis. And so now here, let's looks like a snake as I'm erasing that dotted line there. But now here's my reflection over the x-axis. So I'm still starting at the origin, going down to the minimum, and then coming back up. Alright, so now we got a phase shift, so we got to move everything to the right pi over 2. So here's pi. Pi over 2 is half of that. So this point gets shifted over 1/2 of a pi. This point right here gets shifted over half of a pi. This one gets shifted over. Everything's being shifted over 1/2 of a pi. And with our scale right here, that's what we're looking at. So now our x-intercepts are at pi over 2, and at, I think our next one, let's see, it's pi, so then that would be 3 pi over 2, and so on. And that's what that translated graph would look like, as well as with that reflection. Alright, so I wish we were in class because I would do a ton more examples, but we will use a day to probably make sure that we're good with this. Definitely take your time as you're going through the problems on the assignment and let me know if you have questions.